right, now today what we're doing lesson 2-2. Lesson 2 is all about linear equations. Now this is stuff that you covered back in algebra, so this is kind of just review. Some things that you may see that are new today, though, are something called the standard form of a linear equation, which is what the main part of the lesson is about today. Okay, the standard form. This all goes with your past skill, although in Algebra 2, linear equations are not part of your past skills. They're actually part of Algebra 1. We just use this to build on to that stuff. All right? Now, let's take a look, first of all, at linear. What is the root word of linear? Line. Line, okay. So, line. Any equation that graphs and gives you a line is called a linear equation or a linear relation. Get this out of here. Move this up so you guys can see a little better. All right, so you've got linear relations and you've got non-linear relations. Linear, non-linear. Okay? What do you think a non-linear is? It's not a line. Real simple. Perfect. Okay? All right. Now, there are some basic rules for a linear equation to be a linear without looking at the picture of the equation. All right? We take a look at this one right here. All right? Now, notice, we've got just an x, we've got just a y. There's no powers on those. You're not multiplying the two together. You're not dividing by x's or y's. That makes this one right here linear. On the other hand, do you notice this one right here? Yeah. It's got a y squared. It's nonlinear. It's going to bend. All right? This right here keeps it from being linear. Nonlinear. Okay, this next one, x equals 10. That's fine. You can have one variable or you can have two variables. You don't want any more than two, though. That makes this linear. X is just fine. It's the first power and all that. Look at this one. Notice how x is being, you got the square root of x. Later on this year, you're going to learn how to actually write this as x to the 1/2 power. So you'll notice the x has something other than just the first power. That's what's keeping this from being linear. It's nonlinear. All right, looking at this third one right here. I've got my x, I've got my y. I've got a fraction with x, but that's not a problem. As a matter of fact, this is like y equals mx plus b. Remember that from Algebra 1? Okay, you've got your slope, you've got your y-intercept. That one's linear because you've got a slope, you've got a y-intercept. This one, though, you see the x, y right there? You can't multiply two variables together and keep a line. That's nonlinear. All right, and then this last one right here. Y equals 1/2 x, not a problem. It's got the first power on both the y and the x. That's why you can't see those powers. Look over here, though. See how they're dividing by x? Later on this year, you're going to actually see that rather than writing 1 over x, we'll be writing x to the negative first power. Now, you notice how x has something other than the first power. All right, so our first goal today is to identify linear functions. All right? Looking at this example, state whether g of x equals 2x minus 5 is a linear function. Now remember, g of x from last Thursday, that's just another way of writing y. So if I have y equals 2x minus 5, is that one linear? Yeah. It's got a slope. It's got a y-intercept. There's no powers other than 1 on that y. There's no powers from 1 on that x. So explain. All right? If I would say yes, it's linear. And to explain, I would say slope equals, what is the slope on this one? 2. Okay? And the y-intercept equals negative 5. Perfect. All right? That's all you got to do. That's all you got to do. That's a good enough explanation if it is linear. All right? Okay, on this one, state whether p of x, or we could rewrite that as y equals x to the third plus 2, is a linear function. Why not? Third power. Third power in the x. Perfect. All right. Let's take a look at this one. All right. Once again, instead of t of x, if it makes you easier on you. Excuse me. Okay, exactly. You can rearrange this. That's not a problem. So you could write, if it's easier for you, let's bring the 7x in front. That 4 is positive, so let's do it like that. Is that linear? Yeah, what's the slope? Good. What's the y-intercept? Not 7x, but just 7. All right, so let's take this. We're going to pause the recording for a second while we go ahead and give you a little practice. Okay, Now that you can identify them as linear or nonlinear, if they are linear, we can put them in standard form. Why would we want to do that? Because these calculators that you've got understand it's standard form. Sometimes you want them in standard form, sometimes you want them in slope-intercept form. So standard form has rules that you have to follow. Okay? X and Y have to be on the front. Okay? You have to have a number after the equal sign. The number in front of X, we call that A. That must be a positive number. The number in front of Y, we call that B. Doesn't matter whether it's positive or negative. And this number after the equal sign, we call that C, and it doesn't matter whether it's positive or negative. But no fractions or decimals are allowed. Okay? So I'll show you how to get rid of fractions and decimals here in just a second. An example of something that would be in standard form is this: 3x plus 5y equals negative 12. Something that would not be considered standard form would be negative 3x plus 5y equals 12. What's different? Yeah, this right here has to be positive. Okay? So there's an example. Let's take you through one here. All right, we're right. Y equals 3x minus 9 in standard form. Identify A, B, and C. Okay, that's slope-intercept form. Now, in all honesty, if I had to graph this later on, after today's lesson, it's easier to graph this equation as it is. Y-intercept's negative 9, slope is 3, plot the points, draw the line. But for our practice today, I'm going to go ahead and translate this into standard form. So what I've got to do first is I've got to move this 3x from back over here over to the front. Now what happens when I cross this equal sign right there with anything? It's going to turn negative. Remember, this equal sign is like a switch. If it's positive on this side and it goes over here, it becomes negative. If it's positive over here and it goes over there, it becomes negative. Signs just switch. So when I bring the 3x over, that becomes negative 3x. That y is already positive, equals negative 9. All right? Now, is there any problems with this one?
I find it very interesting.
Y is just fine. Now let me go back to this slide right here.
Divide, right?
Okay, we got to get rid of the negative. It cannot be negative. It's got to be positive. Right? So let's make this positive. We're going to basically mathematically what we're doing, we're multiplying the entire thing by negative 1. But of course that just means we're going to go through and switch all of our signs. All right?
Why'd you talk about negative 1?
Because that changes signs.
Oh, right.
Yep. Okay, so that's step 1. Put it in standard form. Step 2. Let's identify A, B, and C. All right, what is A in this equation? 3. Okay, it's the number that's in front of X. What's B in this equation?
Negative 1.
Negative 1. Notice, remember, if you don't have a number in front of the variable, there's an invisible 1 there. Negative 1. All right, and what's C?
C is 9.
C is 9.
Why not negative 9?
Because it was negative over here, and I multiplied it by a negative 1 to make it positive. I went through and changed all my signs. Okay? All right. Now, I want to go back here to your worksheet here for a second. See, worksheet 2.2. All right. On the top, you've got problems 1 through 4. It says state whether the function is linear. Write yes or no. And then explain. Without an explanation on those 4, there's no credit. Okay? Remember, if it is linear, all you got to do is give me the slope of the y-intercept. If it's not linear, tell me why. And then on problems 5 through 8, write each equation in standard form, identify A, B, and C. 2 parts to each one of those, just like I've done up here on the board. If it's missing either one of those 2 parts, it's not done. Okay? So put it in standard form and identify A, B, and C. That leads us now to, let's just jump right over here and do this.
I hate
Okay.
graphs.
Graphs are easy, Tori. I promise you. You'll love this. Okay. I'm going to go over here and
Oh, good.
Show you something real quick here.
See?
All right, here we got a graph. All right, now, what I want to look at here is a line. We're talking linear, okay? So let's just get a line going up here. I'll just make a line go from here down to there. Let's make it go right to there. Okay, good. All right, some key points on every linear graph are where the graph crosses the x-axis and where it crosses the y-axis. Those are called your intercepts. All right? This one crosses the x-axis right here. That is your x-intercept. What's the coordinates for that point?
Is it
2, 6,
6,
1,
0?
6, 0. Okay.
okay.
That's a 6, 0. That's your x-intercept. Now let's take a look at your y-intercept. It's this point right there. So what's the coordinates?
9.
0, 9. Good. 0, 9. That's your y-intercept. Okay, I want you to notice on your x-intercept, what's y's value? On your x-intercept, what's y's value?
0.
0. On your y-intercept, what's x's value?
0.
Good. Now, once you've got that, that helps us to make this and figure out how to graph this type of problem here. All right, they're going to give you an equation. Step 1, put it in standard form. So I need to move this -4 behind the equal sign, don't I? So that's going to give me negative 2x plus y. Remember, it's crossing over the equal sign, so it becomes positive. Is that standard form? Okay, what do I need to do? Yeah, I'm going to change the signs for everything. X has to be positive. Remember?
You know, it's got a multiple.
Yeah, multiply everything by -1. Signs for everything. That's the same thing. Okay. So this is going to be a positive 2x, a negative y, and a negative 4. Now that's standard notation. That one's good. Okay.
So you have to every time?
Yeah. On these. Okay. Now, to find my intercepts, remember, what was y worth when I was trying to find the x-intercept? 0. All right. Now watch this. If I replace y with 0, then this little thing right there doesn't matter, does it? Negative y has no bearing on anything. So I could just say, all right, that doesn't matter. Let's just do that. And now you can solve this math problem in your head. 2x equals -4. What's x? 2 times something equals -4. What is that something?
-2.
-2. All right. So I know that my x-intercept is -2, 0. I know this thing's going to cross the x-axis right here. All right. Now to find my y-intercept, I know that x has to then be, for the y-intercept, x is going to have a value of 0. And that just means that 2 times 0 is 0, so that gets rid of your whole x term. And now I'm looking at negative y equals -4. If negative y equals -4, what's positive y? Positive 4, okay? So here's 4 right there. That's my y-intercept. 1, 2, 3, 4. Now I know where it crosses the axis. Now I just draw the line, and I move on.
With arrows or...
Yeah, you'll want arrows on the end on this one. Nice and straight if you don't mind. All right. Arrows on the end. And there you go. All right, now, later on, after today's lesson, and they ask you to graph a line. If I've got an equation that's already set up like this one right here, after today, I graph it using slope-intercept form, okay? If it's set up like this, I need to do some work with it. You could do either slope-intercept or you could do standard form. Either way, all right? But that's after today. Today, I want you to practice these. Now, take a look at the bottom 4 problems. Each one of them have an equation. All right? 3 things I need you to do there. Step 1, put them in standard form. Just like I've done right here with this one. I need to get that mark out of the way there. So you can see there. get out of there. You and there.
Wait, so it's
All right.
the same thing?
Standard form is this. Yeah, same stuff we worked on. Like that. Okay. Once it's in standard form, I need you to find the intercepts, just like this. And once you found the intercepts, I need you to graph it. Okay? Any questions? All right, I'm going to let you all get started on that.